So next, we have here the triaxial shear test. So the triaxial shear test is one of the most reliable methods available for determining the shear strength parameters of soil. It is used widely for research and conventional testing. So we have here a diagram of a triaxial testing equipment. So dito, meron tayong tinatawag na specimen. So, yung specimen natin or yung soil, dito natin siya ilalagay. So, dyan natin ilalagay yung ating specimen. So, a specimen is placed in a load frame and yung purpose nitong load frame natin, yung itong load frame natin, is to apply vertical load to a specimen. So, this load is measured by this load cell. So, minimeasure nitong load cell. So, ito, yung ating load cell measuring applied axial load. So, the cell is connected to a pressure and volume control modules. So, nakakonect siya dito. Ito yung tinatawag nating pressure and volume control modules. So the cell is connected to this pressure and volume control modules, which are used, so these are used to regulate and measure the pressure within the cell, as well as to control the drainage ng ating pore fluid dito sa ating specimen. We also have here, ito, yung tinatawag nating computer acquisition system. So, itong computer acquisition system naman controls the test and records the data. So, ito yung nagre-record ng data ng ating soil sample. So, let's take a look at our triaxial cell itself. So, ito. So, this figure illustrates the triaxial cell and explain how it applies stresses to the cell and how it controls yung drainage condition natin. So, yung specimen natin, so we have here the soil sample. This sits on our pedestal inside our cell. So, meron tayong loading cup dyan sa taas. And it is surrounded by an impermeable latex member. So ito, that separates yung soil sample natin doon sa pore fluid from the fluid na nag-fill nung ating cell. So ito yung cell natin. So dito din, so meron din tayong pressure gauges na naka-attach dito sa ating cell. So, yung gauges na yan, yung isa, nagme-measure ng pressure of the fluid. Tapos, yung isa naman, nagme-measure ng pore pressure within the specimen itself. So, there is a valve connected. So, meron din tayong valve dito connected doon sa ating cell, which controls the drainage within the specimen itself. So, this valve can either be closed. So, pag naka-close yung valve natin, this will prevent the drainage. So, ipiprevent niya yung drainage natin. Or, it can also be open, therefore, allowing yung drainage natin dito sa ating soil sample. So, we also have here a loading piston on top of the cell. This allows an axial force to be applied doon sa ating soil specimen. So, ito yung nag-a-allow nung axial force natin na ina-apply natin dito sa ating specimen. So, yung gauges natin, yung gauges natin dito, meron tayong gauges dyan sa top ng ating specimen to measure our vertical deformation. So, meron din tayong naka-attach dito sa taas na gauge that is to measure yung ating vertical deformation. So, we have here the diagram. So, ito yung pressure gauges natin. Ito yung piston natin. Wait. So, ito yung piston natin. Ito yung soil sample natin, yung soil specimen. So, meron tayong valve dito. And yung mga pressure gauges, that is to measure yung pore pressure at pressure ng liquid natin. So, we also have here the terminologies used, yung mga symbols natin used in our topic, shear strength of soil. So, meron tayong theta, that is the angle of failure in shear. Yung ating phi, yung angle ng internal friction. Yung C, yung cohesion ng ating soil. Yung sigma 1, yan yung maximum principal stress natin. Yung sigma 3, yung minimum principal stress natin. At yung ating delta sigma D, yan yung ating additional pressure o yung tinatawag nating deviator stress. So, this induces failure. So, there are two distinct phases of any triaxial test. Yung una, yung consolidation. Ito. And then, yung pangalawa, yung shear phase. So, ito yung two phases of triaxial test. Yung una, yung consolidation. So, during this phase, the cell pressure is increased. So, this provides a uniform confining stress all around doon sa ating specimen equal doon sa ating minor principal axis. So, dito sa consolidation, if we have here our specimen, so meron tayong, this provides a uniform confining stress all around doon sa ating specimen. So, that is yung sigma 3 natin, yung minor principal stress natin na sigma 3. So, ito yung ating specimen. So, meron daw tayong uniform confining stress all around doon sa ating specimen. And during this phase, yung consolidation, the soil may be allowed to consolidate or not depending doon sa ating type ng test. And then yung second phase, the second phase of the test is called the shear phase. So during this phase, a load is applied to the piston on the top of the cell. So this load increases the stress at the top of the cell. So during the shear phase naman, if we have here a soil specimen, meron daw tayong load that will increase yung ating stress on the top of the specimens. And since there are no shear stresses on either top of the side of the specimen, therefore, these planes are the principal planes. So, yung principal planes natin, yung major principal stress natin, yung load natin dito is yung sigma 1, yung pressure na ma-create nung load na in-apply natin on the top of our specimen. So, and yung minor principal axis naman natin na sigma 3 dito sa may side nung ating specimen. So, these vertical stresses gradually increase until yung ating specimen is fail. So that is for the shear phase. So meron tayong sa unang phase, so yung unang phase natin, yung consolidation. So in phase 1, consolidation, pressure is added to the water surrounding the specimen, provided a confining and consolidation stress. So yung ating consolidation, meron tayong two possible drainage condition which are drained or undrained. So, this allows our valve to open or naka-close. Pag drain, naka-open yung valve natin. Pag undrain, hindi naka-open yung valve natin. So, the drainage valve may either be open, allowing drainage, or closed, creating an undrained condition. So, if the valve is closed, yung pag naka-close yung valve natin, we call the test unconsolidated. So, pag naka-close yung valve natin, yung test natin is unconsolidated. And use this symbol letter U to label yung phase natin if our drainage valve is closed in consolidation phase. So, since the specimen is also saturated at the start of yung ating consolidation phase, there can be no change in volume of our specimen. And yung pag-close yung ating valve, wala tayong excess pore pressure na ma-generate during yung consolidation phase. So if the valve is open naman, this specimen is free to drain, and we will call this phase consolidated and use this symbol letter C as its label. So pag open yung ating specimen, free to drain, consolidated yung ating soil. So in this case, pag consolidated yung soil natin, the soil will be allowed to change in volume. So, meron tayong volume change allowed dito. And excess pore pressure will be dissipated by the end of the consolidation phase. Kasi nga naka-open yung ating valve. So, ina-allow niya na ma-dissipate yung ating excess pore pressure. And we have also here the shear phase. So, during yung phase 2, pagkatapos ng phase 1, yung consolidation, meron tayong phase 2, yung shear phase. So, during phase 2, wait. So, during phase 2, the shear phase, again, the drainage valve may be either open or closed. So, pwedeng naka-close yung valve natin or naka-open yung valve natin. Parehas dito sa ating consolidation na pwedeng naka-open or naka-close yung valve natin. So, nasa na tayo? Yan. So, if the valve is open, so pag open naman yung valve natin dito sa phase 2, yung shear phase natin. So, if the valve is open, we call the phase drained. So, doon sa consolidation, pag open yung valve natin, consolidated. Pag open, yung tawag natin consolidated. Dito sa shear phase, pag open yung valve natin, ang tawag natin dyan is drain. And we use letter D as symbol ng ating drain. And in a drain test, the assumption is that there are no excess pore pressures generated during shearing. So, wala tayong excess pore pressure since naka-open nga yung valve ng ating triaxial shear. To ensure that this is the case, so we must run the test very slowly. So, to ensure na walang pore pressure na ma-generate during shearing dito sa ating drainage condition na drain. So, we must run the test very slowly to ensure any pore pressure that might be generated during shearing, so that may time pa to dissipate yung ating pore pressure, yung excess pore pressure natin. So, this is particularly important for clay soils. So, kasi yung clay soils, meron tayong low hydraulic conductivity. So, matagal yung pag-drain ng ating pore pressure. So, if we close naman yung valve natin, so if we close the drainage valve during yung shear phase, we have an undrained test. So, this is represented by the symbol U. So, pag undrained test, there will be no volume change in our specimen in this case, and consequently, yung ating shear-induced excess pore pressure will be generated. So, we commonly measure the pore pressure generated during shear. So, kasi this allow us to compute yung ating effective stress nung ating soil specimen or yung soil sample. So, meron tayo dito, we have here the three standard type of triaxial test. Ito yung tatlo, and meron tayong special type, yung unconfined compression test on yung cohesive soil. So, if you will notice, meron tayong dalawang symbols. So, we use this letter, yung designation natin na letter, to identify the different type of triaxial test. So, yung first letter natin, so the first letter, this specify yung drainage condition natin. So, yung first letter, drainage condition, specifies yung drainage condition natin during consolidation phase. So, during consolidation phase, itong first letter natin. So, drainage condition during the consolidation phase. And yung second naman na letter natin sa ating designation, this specify the drainage condition during shear phase. So, ito yung dalawang phases natin kanina. So, ito during consolidation. So, the first letter specify the drainage condition during the consolidation phase, and yung pangalawang letter naman natin, this specify the drainage condition during yung ating shear phase. So, meron tayo dito the three standard type of triaxial test. Yung una, yung tinatawag nating consolidated drain test. So, we use CD as our symbol. So, the CD test is a consolidated drain test. So, in this test, yung drainage natin is always open. So, yung drainage natin, pag sinabi natin consolidated drain test, is always open. And then, this is also an effective stress yung gagamitin natin pag sinabi nating CD test. Since there are no excess pore pressure that are allowed to accumulate doon sa ating test. So, it is also called an S or slow test, since we have to wait for the consolidation to be completed during yung phase 1 natin, and we have to shear yung ating specimen slowly during yung second phase nung ating test so that no excess for pressure are generated. So we also call this as S or slow test. So next, we have here the unconsolidated undrained test, yung UU test. So the UU test is unconsolidated undrained test. So in this test, yung drainage natin is always closed. So pag sinabay nating unconsolidated undrained test, yung drainage valve natin is always closed. So palaging naka-close yung valve natin. Unlike dito sa consolidated drain na palaging open yung valve natin. So yung gagamitin natin sa UU test or yung unconsolidated undrained test is yung total shear stress natin. Kasi yung we does not usually entail measuring the pore pressure generated kasi yung drainage natin is uh, uh, close. So it is called also Q or quick test since we do not have to wait doon sa ating consolidation nor we do have to wait for the drainage during yung shear phase natin. So that's for the unconsolidated undrained test, yung UU. And meron din tayong consolidated undrained test, yung CU test. So in this test, yung drainage valve natin is open during consolidation and close during shear. So naka-open yung drainage valve natin during our consolidation phase and naka-close during yung shear phase natin. So unlike these two, yung UU test na palaging open and yung CD test, UU test na palaging close and yung CD test na palaging open yung valve natin. Dito sa consolidated and drain test naman, yung consolidation natin, yung valve natin is open and closed during shear. So it is called an R test, presumably because it's faster than S and slower dun sa ating Q test. And during shear, we normally measure yung pore pressure generated during shear. So this allows us to compute both the total and effective stresses during shear. So ito, either total or effective stress yung mako-compute natin. Unlike dito sa unconsolidated undrained, which is the total stress lang, and yung consolidated yung effective stress. And finally, we have sometimes perform yung unconfined compression test on cohesive soil. So, strictly speaking, yung test na ito is not a triaxial test. Hindi talaga ito triaxial test, strictly speaking. So, it is not performed in a triaxial cell. So, it is just a simple compression test without consolidation or any confining pressure. So it is similar to unconfined compression test on a cylinder, on a concrete cylinder, since the test is not performed on the triaxial test. So dito, yung special type natin na UC test, we don't have control in the drainage condition of our specimen. So in this test also, we shear yung soil natin very quickly and assume that there is no drainage. So this test is equivalent to a UU test with sigma 3 equal to 0. So, yung special test natin, yung sigma 3 natin is 0.